Throughout this course, we'll deal with application problems, or word problems as a lot of people refer to them. They can be challenging problems since we have to think a little bit harder about what we need to do to evaluate a problem versus we can get into just sort of a routine and almost automatic approach with some other types of problems. We want to take time this semester to focus on how we pull the information out of a word problem to identify how to approach, how to solve the question being posed. In example 20, we're told that a kayak rental company charges $10.75 an hour H plus $11.25 as a flat fee for the rental. What's the cost of the kayak rental if someone kayaks for 3 hours? I'll fix my little typo there. If someone kayaks for 3 hours. There are a couple of different pieces of information we want to focus on pulling out of this. We know that the goal, ultimately, is to determine the total cost of renting for 3 hours. In order to determine that cost, we have to focus in on the information that we're told there is a $10.75 charge per hour. So that's one critical piece of information. For every hour, we have to pay $10.75. So we could turn that into a mathematical term by writing 10.75 H. In this case, that would be our variable term. And then we have another piece of information that we are also charged an $11.25 flat fee. So flat fee meaning it doesn't matter how long we rent, 1 hour, 12 hours, that flat fee is just a single one-time charge. So we have to add to our hourly rental the $11.25 that we only have to pay once. In this case, that's our constant term. So the first step is translating the information from the word problem into an algebra expression. Once we have that, we can determine the cost of renting the kayak for 3 hours by evaluating this expression, not at x, but at h equals 3, since that's the variable we're using in the problem. So we need to evaluate this expression that we wrote when h is equal to 3. We could do that again with any type of calculator, or we can turn over to Desmos and type in that 10.75 times 3 plus 11.25 to get 43.5 as our solution, or as our answer. So when we plug in h equals 3, we get a value of 43.5. From there, we want to use a little bit of inference to know that this answer should be in terms of money, since it's a cost. So our actual answer would be $43.50, since money always has 2 decimal places. So we identify the information from the problem, use that to construct our algebra expression. We evaluated it for a given value, and then we just had that inferential or contextual step where we had to translate that value into dollars and cents. Similarly, in example 21, we have a bike rental company that charges $10 for the first hour, then $3 per hour H. What's the cost of renting a bike for 4 hours? So in this case, we're told that we have to pay $10 for the first hour. So that's not a variable charge, that's just you pay $10. And then we pay an additional $3 for every hour after that. So that's going to be plus 3h. Then we want to know what's the cost of renting the bike for 4 hours. There's one trick here that if we're paying close attention as we translated this statement, we can pick up on. We're charged $10 for the first hour, then $3 per hour, even though it's not stated, after that first hour. So really what we want to do in this case is evaluate this for when h is equal to 3, not 4, because we're only paying for hours beyond that first hour. Again, we can turn things over to Desmos or use a calculator. In this case, this one's pretty simple to evaluate. This would be 10 plus 3 times 3, or 19. Since this is again about cost, we would want to translate that into dollars, which would make this a total cost of $19 to rent that bike for 4 hours.